This is Mr. Precella working with some unit circle trigonometry today with this trigonometry class. This is the first time we're going to define this the 6 trig functions in terms of the unit circle. But before we do that, we need to review a little bit of geometry. So this is a geometry review. In a 45-90 right triangle, the two legs are equal in length. So if we had a right triangle, where the other two angles are both equal, 45 degrees, then that means the two legs are also equal. Normally we say with the Pythagorean theorem, a squared plus b squared is c squared, but for a 45-90 right triangle, these two sides are the same, so I'll just call both of these a, or you can use whichever letter you want. And let's suppose that the hypotenuse here is a 1. You'll see in a moment why I'm choosing 1 as the hypotenuse. We could use the Pythagorean theorem and we'd have a squared plus, not b squared, but another a squared is 1. So adding those a squared plus a squared, that'd be 2a squared equals 1. Divide both sides by 2. To get a squared equals 1/2. And now let's take a square root. The square root of 1/2, or the square root of 1 is 1. The square root of 2 is 2. When we have a square root in the bottom, we normally rationalize those denominators. So I'll multiply above and below by another square root of 2. So we get, what is that going to be? A square root of 2 on top. And just a 2 on the bottom? Yeah. Square root of 2 times square root of 2 is the square root of 4, which is 2. So if we have a 45-90 right triangle, if the hypotenuse is 1, each of these legs is square root of 2 over 2. Let's review a little more geometry. Let's see what you remember about 30-60-90 right triangles. In a 30-60-90 right triangle, the shortest leg is half the hypotenuse. So in a 30-60-90 right triangle. Let me see if I can draw something that looks like a 30-60-90. So the smaller angle, 30 degrees. If this is a right triangle, then this one here has to be 60 degrees. So let's once again say that the hypotenuse is 1, and you'll see why in a moment, why I'm choosing 1 for the hypotenuse. In a 30-60-90 right triangle, if the hypotenuse is 1, that means the shorter leg, which would be the one opposite the smaller angle, is 1/2 the hypotenuse. So this side here is 1/2. Let's go ahead and solve for this leg. Again, we'll use the Pythagorean theorem. A squared plus, here b is 1/2, so plus b squared equals c squared. The 1/2 squared would be 1/4, and of course 1 squared is just a 1. So I would subtract the 1/4 from both sides. 1 minus 1/4. That would be 4 over 4 minus 1/4, or is 3/4, or 1 pizza minus 1/4 of the pizza is 3/4 of the pizza. And now take a square root, and we don't have to rationalize on this. It's square root of 3 over 2. Now I said that this is going to be some unit circle trigonometry here. Well, what the heck is a unit circle? Well, the unit circle is, of course, a circle centered at the origin 0, 0, with radius equal to 1. Just take a brief look. Here's an example of a unit circle centered at 0, 0, radius of 1. And notice how all these angles are cut off. On the unit circle, the points of intersection made by the terminal side of theta and the circle are in the form: the x-coordinate is cosine theta, the y-coordinate is sine theta. X-coordinates are cosine theta, the y-coordinates are sine theta. They're in alphabetical order. So looking back at this unit circle, you'll notice our degree measurements are here. I just printed this out from embeddedmath.com. It's a nice little website where you want to print out some blank unit circles or some graph paper or so forth. They have a lot of nice little things there that are free. So I'm just using their unit circle. And on their unit circle, their blank unit circle, oops, there go the lights, are almost too blank. So I've written in the degree measurements here. And what we're going to do is go around the unit circle and fill in these points using what we know about 45, 45, 90 and 30, 60, 90 right triangles. But the first thing we're going to do is let's fill out the 4 points that are actually on the x-axis and y-axis. Right here at 0 degrees, if this is a circle with radius 1, then this point right here would be the point right 1 up 0. At 90 degrees, this would be the point over 0 up 1. Again, this is radius 1. A circle centered at the origin with radius 1. Right here at 180 degrees, this ordered pair would be negative 1, 0. And finally, 270 over 0 down 1. Let me see if I can sort of unzoom so I can get this whole unit circle showing. Okay, let me see if I can just lift it up a little better. There, the whole unit circle is showing now. Again, the key here is to remember that the radius is 1. Now let's look at the 45 degree ones. Those are going to be the 4 angles that end in 5 degrees. Those 4 angles, we say that 45 degrees is the reference angle. Imagine dropping a perpendicular down here and forming a 45, 45, 90 right triangle. If you do that, then you're going to have this triangle right here. This is the radius. Okay, it's the radius. And then these two sides here would be equal. So both of these sides are square root of 2 over 2. That's at 45 degrees. And now we can go around to all the other ones that have 45 degrees as their reference angle. The ones that end in 5 degrees. And you can almost imagine dropping a perpendicular, you'd have that 45, 45, 90 right triangle. So this point of intersection is going to be the same thing we have over here, except in the second quadrant, x's are negative. So this would be negative square root of 2 over 2, comma positive square root of 2 over 2. At 225 degrees, you're in the third quadrant. Both of these are negative. And finally, at 315 degrees, both of these are, no, x is positive, y is negative. So realize what we're doing here. By definition, I said that these points of intersection are in the form cosine theta, comma sine theta. So the cosine of 0 degrees is 1. The cosine of sine of 0 degrees is 0. Okay, at 135 degrees. The cosine of 135 degrees is negative square root of 2 over 2. The sine of 135 degrees is positive square root of 2 over 2. And so forth. Now let's do the ones that have 30 degrees as their reference angle. Well, that's that 30, 60, 90 right triangle. Pull it up, right out here. And a 30, 60, 90. You see this purple triangle is this one right here. If you sort of drop a perpendicular there. I don't want to get this thing looking too messy. That's why I'm not drawing it. But that would mean that the x is square root of 3 over 2. The y is 1/2. Now, all of these, that are the 4 that are closest to the x-axis, have those same points of intersection. The ones that have 30 degrees as the reference angle will be 150 degrees, 210, 330. You can almost imagine dropping a perpendicular and getting one of those 30, 60, 90 right triangles. So we're going to take these same ordered pairs, move them around. Over here in quadrant 2, x is negative, y is positive. In quadrant 3, they're both negative. Negative square root of 3 over 2, negative 1/2. In quadrant 4, x is positive, y is negative. And then at 60 degrees, it's just these reversed. If you took your right 30, 60, 90 right triangle and moved it around so that the 60 were down here, then the important thing is the side opposite the 60, that's the longer side. The side opposite the smaller angle would be the shorter side. And so at the 60 degree reference angles, let me see what color do I use. I'll use purple. It's just going to be these points only reversed. 1/2 square root of 3 over 2. Negative 1/2 square root of 3 over 2. Negative 1/2 negative square root of 3 over 2. In quadrant 4, x is positive, y is negative. Ooh, negative. So there's our unit circle with the points of intersection filled out. You're going to need to get very, very familiar with this. Okay. Texas Higher Education Coordinating Board has said that students are supposed to have this unit circle and know how to use, supposed to have the unit circle memorized and know how to calculate trig functions using this unit circle. So we need to pay close attention to this and notice there are patterns. If you know these 3 points, then you can sure fill in the rest of them. Okay? The purple ones are all of the 60-degree reference angles. Well, the blue here, the ones that end in 5 degrees, 45 degrees, then I sort of switched colors, didn't I? The 30-degree ones are the square root of 3 over 2, comma 1/2. And then the ones on the x and y axis, those are the ones that have 1s and 0s. So if we have that unit circle memorized, I mean you need to have this thing memorized, then the assignment here in this homework is going to be pretty easy. Going problem number 1, this is our table, and you're given 225 degrees, and we're trying to fill in these boxes here. Well, some of these are already filled in. They're telling you, here's 225 degrees right there. The x and y are both negative square root of 2 over 2. So tangent, that would be sine over cosine. Anything over itself, that's a 1. Cotangent is cosine over sine, or you might think the reciprocal of tangent, which is still a 1. Cosecant is the reciprocal of cosine. So cosecant is the reciprocal of sine, and just based on what we're getting here, you can almost sort of think, okay, it must be the same thing because you're just flipping this. Could y'all go through and do that arithmetic? Flip this, flip negative 2 over the square root of 2, and then rationalize by multiplying above and below by square root of 2. So you'd have negative 2 square root of 2 all over 2, negative square root of 2. So those are the same, because these are the same. Now here's one where none of it's done for you already. It says find the exact values of using the angle 150 degrees. So look at 150 degrees on the unit circle. Here's this point of intersection. By the way, if you're thinking, what about these little blanks here? We'll fill those in the next time. Okay? That's where we'll introduce another angle measuring system, something called radians. Okay, so to fill all of this in, sine 150 degrees. At this point of intersection, the first number is cosine, the second number is sine. So 1/2 negative square root of 3 over 2. Now tangent's going to take a little bit of work. You go sine over cosine. So that would be, I'm doing tangent right here, 1/2 all over negative square root of 3 over 2. I'll multiply above and below by 2. So you get a negative 1 over square root of 3. We got to rationalize that. So multiply above and below by square root of 3 over square root of 3. And we would get a negative square root of 3 all over 3. Okay. Next, we're going to find cotangent 150 degrees. Well, there's a couple of ways we could do that. We could do what we did here and go cosine over sine. Or, if you want to think, okay, flip, you could either flip this, but if you flip this one, you're going to have to rationalize it. The smart person would flip this. This pink one here, negative 1 over square root of 3. If you flip that, it's just negative square root of 3. No rationalizing needed. Let me focus a little better. Okay. Now we're up to secant 150 degrees. Well, secant is the reciprocal of cosine. So take cosine and flip it. We'd have negative 2 over the square root of 3. Rationalize. And you're going to have negative 2 square root of 3 all over 3. And cosecant is the reciprocal of sine. So just flip sine 150 degrees. Now that's easy. Flipping 1/2, you're just going to get a 2. Okay. This is some unit circle trigonometry. The key is on the unit circle, the x coordinates are the cosine value, the y coordinates are the sine value. Let me go ahead and make a note of that. They're in this order: cosine theta, comma, sine theta. They're alphabetical. And up here, where it says positive, negative, well, all of the trig functions are positive in quadrant 1. Here, let's see. Cosine is negative. Sine is positive. So sine theta would be positive. Now sine over cosine tangent, that would be negative, along with cosine theta. In the third quadrant, in the third quadrant, cosine and sine are both negative, but tangent, sine over cosine, that would be positive. By the way, I'm not writing the reciprocals. If tangent's positive, so is cotangent. If secant's cosine's negative, so is secant. In the fourth quadrant, cosine's positive, sine is negative, the y coordinates. Sine over cosine tangent would also be negative. So let's look at this one here. I've just printed out a whole lot of examples here. Sine 45 degrees plus cosine 30 degrees. Sine 45 would be square root of 2 over 2. Cosine of 30, that would be, oh wait, let me see, let me move this over. Okay, so sine 45 degrees, square root of 2 over 2. The cosine of 30 degrees, at 30 degrees, that x coordinate, square root of 3 over 2. Now you can't add the square root of 2 and the square root of 3 and get square root of 5. No, no, no. All you can do is just write it as one fraction. Square root of 2 plus the square root of 3 all over 5, all over 2. Number 4, sine 90 degrees plus tangent 45 degrees. Let me move the unit circle over so you can see. Sine, that's the y coordinate. So 1 plus tangent 45 degrees. At 45 degrees, sine over cosine, since both of these numbers are the same, sine over cosine, that would be 1. So 1 plus 1 equals 2. This undefined would have happened if you'd gotten like 1 over 0, tangent 90 degrees, for instance. 1 over 0, remember 0 in the bottom of a fraction means undefined. What about sine 30 degrees times cosine 60 degrees? The purpose of these problems is just to familiarize yourself with that unit circle. sine 30 degrees, that would be 1/2, times cosine 60 at 60 degrees. Cosine of 60 degrees, that would be 1/2 also. So 1/4. What about cosecant 30 degrees times tangent 45 degrees? Cosecant 30. That means go to 30 degrees and flip which one of these? The sine value. So cosecant 30, when you flip 1/2, you get a 2. Now what about the tangent of 45 degrees? Sine over cosine. These were the x and y coordinates are the same. That's where you're going to be getting 1 for tangent. As you move around from quadrant to quadrant, it might be -1. Oh, look at this one. Number 7. 7 times sine 90 degrees minus 5 times cosine 180. So we have the 7. And in this blue, I'm going to figure out sine 90 degrees. 90 degrees, the sine value is the y coordinate. So 7 times 1 minus 5. In purple, let me write cosine 180. What's cosine of 180 degrees? Let me move my unit circle. At 180 degrees, the cosine value is -1. So we would have what? A 7 wait, is that going to be a -5 or a +5? It's going to be a +5, isn't it? Negative times negative. So 12 let's see. Let's look at this one here. We're told to find the exact values of the 6 trig functions. It says don't use a calculator. Okay, you need to get familiar with doing this with the unit circle. Okay, and if you're in the online class, it's going to be tempted just, I don't need to memorize this. I'll just punch it in my calculator. There's going to be some stuff later on where you just have to know that unit circle when we're solving trig equations. You're not going to be able to do that with the calculator. So take the time and memorize this unit circle now. You'll be grateful in the long run. Let's see now. First glance, when you see 420, you think that's not an angle on the unit circle. But remember, we've already mentioned if you have an angle bigger than 360, that just means that it's looped around. So if you have an angle bigger than 360, just subtract 360 until you get an angle between 0 and 360. At 420 degrees, if I subtracted 360, I'd get 60 degrees. 420 degrees looks like this. You loop around once, and then move an additional 60 degrees. That would be 420. So we say that 420 degrees and 60 degrees are coterminal. On the unit circle, you would loop around once and then stop at 60 degrees. So I'm looking at this point of intersection right here, 60 degrees, cosine, sine. So the cosine of 420 degrees is 1/2. The sine of 420 degrees is square root of 3 over 2. Things I'm circling are the things you would type in. Now tangent That's sine over cosine. Can y'all see? For tangent, 420. Let me do it right here. Sine, square root of 3 over 2, all over 1/2. I would just multiply above and below by 2. And all you have left is square root of 3 over 1, which is just square root of 3. Now, cotangent, square root of, 420 degrees. Cotangent would be the reciprocal of tangent. So 1 over square root of 3. We need to rationalize. So I'll multiply above and below by square root of 3. That's that little invisible orange ink I'm using there. So we would have what? A square root of 3 all over 3. Secant, 420 degrees, is the reciprocal of cosine. So we can do that pretty easily. Flipping 1/2, we get a 2. And the last page, cosecant 420 degrees. So you're going to flip sine 420 degrees, which we had found to be square root of 3 over 2. So flipping that, we'd have 2 over the square root of 3, which you're going to have to rationalize. So we would get 2 square root of 3 all over 3. Okay. Let me sort of flip through and find some more. Just looking through, printing out a whole lot of problems. So use another one like that. So the angle measurement is a negative angle measurement. Now there's not negative angle measurements labeled on the unit circle, though we could certainly go through and label them if you want. Remember, with the negative angle, you start at the positive x-axis and you move clockwise. So this would be negative 30 degrees, negative 45 degrees, negative 60, negative 90. It's just these angles making them negative. What you could do if you have an angle that's negative, just add 360 to it. Add a multiple of 360. Keep adding 360 until you get an angle between 0 and 360 degrees. Negative 45 plus 360 is 315 degrees. And if we just started here and moved 45 degrees, here's negative 30, negative 45. See, negative 45 degrees is coterminal with 315 degrees. So we're going to be looking at 315 degrees when we're doing this. See if I can get this on a bit. So 315 degrees, we're using the square root of 2 over 2, comma negative square root of 2 over 2. Sine would be the y-coordinate, negative square root of 2 over 2. Cosine is positive square root of 2 over 2. Tangent, sine over cosine. Can y'all do that in your head? Negative square root of 2 over 2 over positive square root of 2 over 2. That would be a negative 1. Oh, pardon me. Now let's see. What about these reciprocals? It asks for cosecant. Well, cosecant would be the reciprocal of sine. So we're going to flip this negative square root of 2 over 2 to get negative 2 over square root of 2. And we'll rationalize by multiplying above and below by square root of 2. So we have negative 2 square root of 2 all over 2. The 2's cancel. You're going to do this so much, you'll get to a point where eventually you'll be able to say, okay, the reciprocal of negative square root of 2 over 2 is negative square root of 2. You might just want to remember those are reciprocals of each other. Square root of 2 over 2 and square root of 2. Oh, secant negative 45 degrees. Well, if we flip cosine negative 45 degrees, we're going to get exactly what we have here, except we don't have the minus. The reciprocal of square root of 2 over 2 is square root of 2. One more. Which one have we not done? Cotangent. Cotangent negative 45 degrees. That means flip tangent negative 45 degrees. The reciprocal of negative 1 is just negative 1. Let me get some for 210 degrees, 315 degrees. Those are on the unit circle. That's why I printed out so many of them. This one here, number 14, I don't know why it's multiple choice. It should be easy to type it in. Go ahead and find cosecant 90 degrees. That means at 90 degrees, take the sine of 90 and flip it. So flipping this pink 1, you're still going to just get a 1. Here's a good one, number 15. Notice the angle is a lot bigger than 360 degrees. So just rotate around by subtracting 360 degrees until you get an angle between 0 and 360 degrees. If we actually divided 2,745 by 360, we would get 7. We're going to loop around 7 times. Loop 7 times. That would be 360 times 7, which would be 2,520. 2,520 degrees would be looping around here 7 times. So once you've looped around 7 times, you then go an additional, what's 2745 minus 2520? Well, 225 degrees. So the angle that you're going to look at on the unit circle is here at 225 degrees. At 225 degrees, cosine and sine are both negative square root of 2 over 2. So if you find the correct coterminal angle, it's hard to get it wrong then. Negative square root of 2 over 2. Let's see. Are there some more like that? Yeah. Number 2004, tangent 2,490 degrees. Literally just start subtracting 360 until you get an angle between 0 and 360 degrees. On this one, you loop around. I'm thinking 360 goes into 2,490 degrees 6 times. You're looping 6 times. How did I do that? 2490 divided by 360 is 6 with a remainder. 360 degrees times 6 is 2,160 degrees. So 2490 minus 2,160 degrees. Literally, all you've got to do, I did my calculator, is just start subtracting 360 on your calculator. Oops. 2490, and now just start subtracting 360 until you get an angle between 0 and 360. We're getting close. 330 degrees. That means that 2,490 degrees is coterminal with 330 degrees. So you look at 330 degrees on the unit circle. Let me find that. 330. Sine over cosine It's right here at 330 degrees. Sine over cosine, that would be a negative 1/2 over square root of 3 over 2. Let's see what we would have there. Negative 1/2, that's sine, over cosine, square root of 3 over 2. And then we simplify by multiplying above and below by 2. Oh, they're cutting the lights off on it. We'd have a negative 1 over the square root of 3. And once you do enough of these, you're going to be able to rationalize this in your head. Negative square root of 3 over 3. Do number 18, that ease up a little. So number 17, that negative 2,295. Just add 360, negative 2,295. Just start adding 360. Plus 360, plus 360, plus 360, plus 360, plus 360, plus 360, getting close, plus 360, 225 degrees. So that means it's negative 2,295 is coterminal with 225 degrees. How did I get that 225 degrees? Just add 360 until you get an angle between 0 and 360. If the angle is bigger than 360 degrees, positive, subtract 360. So cotangent 225 degrees. That would be right. Let me see how to do this. Well, I'll do it like this. 225 degrees, cosine over sine. At 225 degrees, cotangent is that going to be a positive 1, negative square root of 2 over 2 over negative square root of 2 over 2. And then what's hit number 18, sine over cosine, 1/2. Tangent 30 degrees, sine over cosine, 1/2 over the square root of 3 over 2. That would be 1 over the square root of 3, which rationalizes to square root of 3 over 3. Let me see. Anything else here that looks... Nope. No, the rest of them just look like straightforward. Look at the unit circle. Again, do this with unit circle. Don't just punch it into your calculator. Okay? So that's the unit circle definition of the 6 trig functions, and it's a biggie. So we've defined the trig functions 3 ways. First was x, y, r. Second, using SOHCAHTOA and right triangles. And here's our third and final definition, the unit circle definition. For the x coordinates on the unit circle are the x values, the y coordinates are the x coordinates are the cosine values, the y coordinates are the sine values. So we better call it quits there, we're out of time. Okay, bye-bye.